guys, welcome back. So what we're looking at today is lesson 6 and 7. So we're looking at 2 lessons today. We're going to start with lesson 6, using equations to solve problems. So what we're looking at here is concert ticket sales. A performer expects to sell 5,000 tickets for an upcoming concert. They want to make a total of 311,000 in sales from these tickets. Assuming that all tickets have the same price, what is the price for one ticket? Well, if the total that they want to make from those tickets is 311,000 divided by the 5,000. When we divide those, we're going to find that it's $62.20. So $62.20 per ticket. So based on that, how much will they make if they sell 7,000 tickets? So we take the 62.20 times 7,000, and we're going to get $435,000. A lot of money. What if they sell 10,000 tickets? So taking the 62.20 times 10,000, that's going to get us 622,000. If it's 50,000, that'll get us $3,110,000 on all of these. If they sell 120,000, lots of tickets, obviously. Multiply that by the 62.20. We're going to have 7,464,000. If they sell 1,000,000 tickets, it's going to be 62,200,000. And if they sell X number of tickets, 62.2x. We just take however many tickets, just like we did for all of these. We take how many tickets there were that they sold and multiplied it by the price per ticket. For number 4, if they make 379,420, how many tickets have they sold? Well, if we know that this is how we find how much they made, we can set that equal to how much they did make to find out how many tickets they sold. So we're just going to take the 379,420 and divide it by the 62.2. So 379,420 divided by 62.2. That's going to get 6,100 tickets. So we just did 379,420 divided by 62.2. So how many tickets will they have to sell to make 5 million? So same idea. 5 million equals the 62.2x divide by 60. Oops, it's supposed to be 62. 62.2 divide by 62.2. And when we take 5 million, divide it by 62.2, we end up with 80,386. We had to round it to get that. When we calculate it, we would actually find it's 80,385.85. So obviously we can't sell a portion of a ticket, so we rounded up to the nearest ticket for that. So that's how many tickets they would have to sell. So we created an equation, in a sense, to take and solve these. So we found that relationship. So relationship is your keyword for this lesson, relationship. All right, recycling. Aluminum cans can be recycled instead of being thrown in the garbage. The weight of 10 aluminum cans is 16/100ths of a kilogram. The aluminum in 10 cans that are recycled has a value of 14 cents. If a family threw away 2.4 kilograms of aluminum in a month, how many cans did they throw away? Explain the reasoning. So we know that 10 cans is 0.16, and so if we multiply that together, that's going to get us 0.16 times 10 is, wait, sorry, my brain. So 2.4 is 0.16 times 15, and 10 times 15 equals 150. So if we take the 2.4 and divide it by the 16, that's how we got the 15. So taking 2.4 and dividing it by 0.16 equals 15. So that's how we got that 15 there. And then 10 times 15, because there's 10 aluminum cans for each. So it'd be 150 cans. All right, what would be the recycled value for those same cans? So we know there's 15, or we know the 15. So we're going to take 0.14 times 15, which equals 2.1. So $2.10. So we only use the 15 here because 10 cans has a recycled value of 14 cents. So that's why we don't need to multiply the 10 and 15 together, because we know every 10 cans, there's 15 groups of every 10 cans in the 150 cans. All right, write the equation to represent the number of cans C given their weight W. So C equals, if we're looking at it in terms of weight, we'd have 62.5 W. Write the equation represent the recycled value of, right? Recycled value R of cans, of C cans. Sorry, letters in there. Had me having issues. Okay, so R equals 0.014 C. Now, we move the decimal in this because this is for 10 cans. So we want to have it for when it's 1 can, would be essentially 1 cent, or 14 thousandths of a cent. And write an equation to represent the recycled value R of W kilograms of aluminum. So this will give us R equals 0.875. So there we have that value there as well. So different equations that we can make based off different parts of this, using finding what that value is for just one, looking at it in terms of 1 versus 10, and so forth. All right, so now we're going to jump into lesson 7. Lesson 7 here, comparing relationships with tables. So more with relationships. So visiting the state park. Entrance to a state park costs $6 per vehicle, plus $2 per person in the vehicle. How much would it cost for a car with 2 people to enter the park? 4 people? 10 people? So if we have a car, that's automatically $6. And then there's 2 people in the vehicle, so 2 times 2 is going to give us $4 more. So 6 plus 4 is $10. Ooh, you can't see that. Hang on. Bigger. Thought I did. That will give us $10. Now, if there's 4 people in the car, we know we've already got the 6, and we know with 2 people, it gets us 10. So another 2 people added to that is another $4, so it's 14. Now we jumped all the way up to 10. So 10 people times 2 people, or $2 per person. 10 times 2 is 20, plus the $6 fee for the vehicle. It's $26. So for each row in the table, if each person splits the entrance cost equally, how much will each person pay? So with 2 people, 10 divided by 2 is 5. With 14 people, not 14 people. With 4 people, 14 divided by 4 is 350. And for 10 people, 26 divided by 10 is 2.6. So obviously, the more people there are, yes, the more the entrance fee is, but you have more people to contribute towards it, so it ends up being less that you pay per person for it. So how might you determine the entrance cost for a bus with 50 people? So obviously we know it's still going to cost that initial $6. So $6 for vehicle. Then 50 times 2 is 100, which will give us $106. Is the relationship between the number of people and the total entrance cost a proportional relationship? No, this is not proportional. So cost per person is not the same for different numbers of people. So that's what makes a proportional relationship. Because there's that base fee of the $6 for the vehicle, that's what makes it so it's not a proportional relationship. Proportional means that if we that it's going to go the same amount each and every time. And when we divide like our entrance cost by a number of people in a vehicle, we should get the same amount every single time, and we're not. So that's how we can tell it's not proportional. All right, running laps. Han and Claire were running laps around the track. The coach recorded their times at the end of laps 2, 4, 6, and 8. So here's Han's, and then Claire's is down here. Is Han running at a constant pace? Is Claire? How do you know? And then we're going to write an equation for each. So let's start with Han. Time, 4 minutes, laps 2. 4 divided by 2 is 2. Then we're going to take time, 9 divided by 4 laps is 2.25. Then 15 divided by 6 is 2.5. And then 23 divided by 8 is 2.875. So the longer he ran for, the more time it took to do the same number of laps. So to do a lap, it took longer each time as he continued to run. So is Han running at a constant pace? Not constant, which means he's also not a proportional relationship. All right, now for Claire, we're going to take 5 and divide it by 2, which is going to give us 2.5. We're going to take 10 and divide it by 4, which also gives us 2.5. 15 and divide it by 6, which is 2.5. And 20 divided by 8, which is 2.5. So hers was the same every single time. So no matter how long she ran for, she always had the same amount of time per lap. So yes, constant. Now, for writing the equation to represent the distance and time for anyone with constant, that'd be Claire's. So I can't write one for Hans, but Claire's, we'd have time equals 2.5 times the distance. So however long she ran for, multiply it by 2.5 because that's minutes per lap, and that will get you her total amount of time she ran for. All right, so if you guys have any questions, feel free to ask. Have a wonderful day, you guys. Bye.